since man's first thought, he has striven to understand and master matter and the elements, organize chaos, channel energy. Just as water is essential for life, scientific knowledge and research cannot be dissociated from the history of mankind. The CNRS was founded in 1939 to unify and stimulate research and to support the war effort. When peace returned, the CNRS carried on its mission to further French science and research. Today, the CNRS is a network that spreads across the nation, with over 1,000 laboratories mobilizing up to 30,000 people. The institution is renowned and respected by the scientific communities in Europe and the world. Research is always a three-tier process, regardless of the science concerned. The first phase, long and wide-ranging, concerns fundamental research. It accompanies scientists' deliberations on fundamental questions of knowledge. While the ultimate goal is to find, science cannot progress without the freedom to search and to make chance discoveries. In 1969, when the young research scientist Albert Fer was working on his PhD on nuclear magnetic resonance, he undertook fundamental research on the properties of the electron spin. No applications had been envisaged at the time. His research led to the major discovery of giant magnetic resistance and spintronics. In 2007, he and German scientist Peter Grunberg, who shares the credit for this discovery, were awarded the Nobel Prize. Under the aegis of the CNRS, Albert Fer epitomizes the exemplary links between academia and fundamental research, technological research and applications, and partnerships with industry and the private sector. The second phase of research is socio-economic. It covers applied research, major avenues of research, and programs and strategies. Today, spintronic applications are used in computer hard disks, mobile telephones, and nomadic technology. Storage capacities have increased 100-fold. The third phase of research comes when crises and challenges require urgent action and teamwork. In 2006, the chikungunya epidemic hit several regions, including Reunion Island. The vector is a mosquito, the Aedes, known as the tiger mosquito. The CNRS mobilized teams in entomology, virology, chemistry, and the life sciences, but also helped to keep the field workers managing the virus with the populations fully and appropriately informed. Eradicating the vector is just as important as understanding the habits of the local populations in order to target the mosquito's lairs. Today, this phase of the epidemic is under control, but monitoring units are still in place to observe the migrations of the vector, which is now shifting northwards due to global warming. The CNRS helps us to relive antiquity and make the past our own, from the most ancient object to modern reproductions. Archaeologists and paleontologists work with computer scientists, climatologists collaborate with hydrologists, and virologists team up with physicists and mathematicians. One of the main roles of the CNRS is to break down the barriers between disciplines and to emulate data transfer. It encourages cooperation between the sciences and favors cross-disciplinary transfer of knowledge. The hardships caused by the African monsoon condition the lives of 300 million people in an area covering 7.8 million square kilometers. Thanks to high-resolution data from second-generation satellites, storm formations are followed in real time, and continents and oceans can be probed in order to understand climate mechanisms, both locally and globally. Convective systems developed in Europe have been adapted for studies in West Africa. A North-South dialogue has opened up. The AMMA program has highlighted the correlation between natural phenomena and those caused by man. Researchers have established that the interaction between wind-borne mineral dust and residual smoke produced by burning the biomass has modified the monsoon regime. Added to these factors are variations in the temperature of the oceans and urban pollution phenomena. Studying this data has produced new understanding of the links between these local and regional phenomena and the evolution in the Earth's climate. The CNRS works for sustainable development. Nature is a sanctuary. The scientists at the CNRS help to preserve it, understand its mechanisms, and use its infinite resources with due respect for biodiversity. They wage a battle against ignorance and short-term concerns. The race is on to develop sources of biodiversity before the Earth's non-renewable energies have dried up. The ethnologist Maurice Godelier urges research scientists to split their time between studying and field trips. In the heart of the primary forest in French Guiana, in the vast Amazonian basin, CNRS research scientists have created an open-air laboratory, the Nurag Field Station. The station is the radical application of this credo. Here the laboratory is in the midst of the forest, in direct contact with the objects of the study. Of the estimated 350,000 plant and animal species that cohabit here, barely 5% have been classified or recorded. Research scientists from the CNRS and their colleagues from around the world make indexes, take photographs, and collect samples. The specimens, samples and observations they garner will be sent to supply laboratories across the globe. Tomorrow, they will help to identify new active principles. The study of nature reveals perspectives for innovation, for it still holds countless secrets, such as the remarkable models of biological systems that put even our boldest technological achievements in the shade. In order to get close to this world, the CNRS has set up the COPAS, the Canopy Operating Permanent Access System. The canopy is a world in itself, an interface between sky and earth. COPAS endows the CNRS with a system that can be used to study the canopy, the fauna that inhabits it, and the phenomena it generates all year round. COPAS offers a better understanding of the forest and its gas exchanges and of its role in the ecosystem. Nature is an alembic, but its cycles are slow. The CNRS strives to speed up its rhythms and uncover its secrets. It is from the leaf of the yew tree that Pierre Potier isolated the active principle of one of the most widely used anti-cancer treatments in the world, Taxotere, notably to treat breast cancer and prostate cancer. In order to develop groundbreaking drugs, biologists, physicists and computer scientists join forces to mathematically simulate what will occur when active principles come into contact with viruses such as H5N1, HIV and countless others, gaining precious time for experimentation. Thanks to research carried out by the CNRS and its partnerships with the INSERM and pharmaceutical laboratories, tomorrow new drugs will treat illnesses that today's medicines cannot yet cure. To accomplish this, they require vast calculation and data computing means. Needs are growing exponentially. The human sciences, chemistry, life sciences, mathematics, and earth and space sciences all require increasingly high-performance machines. The CNRS is equipped with one of the most powerful supercalculators in the world, the IBM Blue Gene. It also participates in the EG calculation grid that links over 40 countries and mutualizes clusters of personal computers. The CNRS has recently set up the Grid Institute, which federates 30 of the laboratories that accumulate 80% of French calculation grid activity. The CNRS is continuously elaborating new networks and optimizing their connections. To guard against potential natural disasters, networks of captors are placed at the nerve centers of regions at risk, and millions of data are then analyzed. Risk agencies are being created in order to combat potential catastrophes and save lives and property. The studies they carry out span everything from local zones to entire regions. The CNRS steps beyond the boundaries of knowledge. Worldwide cooperation becomes a space unencumbered by gravity. As knowledge, tools, and technological platforms grow, from telescope to microscope, the limits of the infinitely large and the infinitely small recede. Exploration of these domains form the two extremes of scientific research. While fresh light is constantly shed, new dark areas appear too, arousing our curiosity. Certain particles exist only in the form of equations. These theories need to be validated. The CNRS and the IN2P3, the Institute of Nuclear Physics and Particles, have teamed up with CERN to try to recreate life before life over infinitely small periods of time and simulate phenomena of the infinitely large that cover infinite durations. It takes light, i.e. a photon, just a few femtoseconds to travel the width of a strand of hair. Yet the same photon can take billions of light years to reach us from the confines of the universe. Understanding the origin and mechanisms of elementary particles would help us to glimpse the origins of the world. At the Auger Observatory in Argentina, which covers an area of over 3,000 square kilometers, 1,600 tanks collect highly ionized particles and enable physicists to retrace the genesis of the path these cosmic bodies have taken. As they travel through the tanks, the particles generate a few photons that are then analyzed. As soon as the observatory was operational, it started to deliver information that exceeded the research scientists' highest hopes. This observatory, the only one of its kind in the world, came about thanks to the determination of CNRS research scientists. When our research scientists tried to recreate the phenomena of elementary particles, they launched probes to chase after comets, the vestiges of the solar system. The Rosetta probe has set off to meet the Churyumov-Gerasimenko comet, which it will reach in 2014. It will enter into orbit around its core, take photographs of it, then launch its lander, Philae. Several measuring tools developed with the aid of CNRS scientists will analyze the surface and the matter of this fossil that dates back to the very origins of the world. Are we alone in the universe? Are we a link in an ongoing evolution that could have occurred somewhere else in space? Or simply the product of chance? From the infinitely small to the infinitely large, the CNRS covers every field of science and research and plays a vital part in the conquest of knowledge on the move.